Hey guys, today I'm going to show you how you can bring relevance to your classroom using a real-life data set using Desmos, Google Sheets, and some data from Wikipedia. So let's jump into it. So the example I'm going to show you utilizes the 100-meter dash times, the progression of the 100-meter dash times over the years since, I want to say 1912. And I use this in a Algebra 1 classroom, but I've used it in Algebra 2, and if you have a good group of 8th graders, you could possibly use it in 8th grade as well. And I decided to start using this data set for the obvious reasons. Students are complaining, when are we ever going to use this? They don't see the relevance of it. So I think bringing in a real data set, that has physical meaning really goes a long way in showing, how the math that we're using is relevant to understanding our world. So what I do is I just went and I searched and I found this chart from Wikipedia that shows the world record progression. And I'm just going to copy this chart. I'm going to scroll down and copy this chart where it starts at 1912. And I'm just going to right-click, copy, take that over to a Google Sheet, and I can Control-V to paste. And there it goes. Now, all I really care about is the date and the world record time. So I'm just going to delete these columns. I'm going to delete this reference column. If I could find the delete button. And there we go. Maybe resize this. I guess I cut off my T, but that's okay. And something that Wikipedia does is these, I believe, are hand-timed. And then it says that in 1977 they switched to fully automatic timing. So I go through and I pick it back up. This leaves off at 76. So let's pick it back up at the first date after 76. And we're gonna tack those on as well. Some people might argue, well, one group's hand timed, the other group's not hand timed. They're not quite the same. And I'll leave that up to you. If you don't want to include these last values, go for it. I will say I think my kids like including these because they recognize this name Usain Bolt, and so it's just something that they're familiar with, so they kind of like that a little better. So I'm just going to delete, again, all the cells that really we don't need. All right. Now the next thing I like to do is just go ahead and create borders. And notice that there are multiple times that got achieved at different dates. Right? 10.6 happened twice on two different dates, 10.4s, et cetera, et cetera. So I'm going to unmerge these cells because I want every date to have a year right by it. So what I'm going to do is I'm just going to unmerge these, and I'll show you how you can quickly fill these in. If you just click on it, drag this bottom right corner, it's going to fill in with the date, or I'm sorry, the time, not the date. So here we go. And we can just do this. We're just cleaning up the data. Now I will say, it just kind of depends on the class that I have. If my class is a class I think that can handle this, I might just print out some instructions on how I want them to clean up the data. If it's a class that I'm not sure they're going to be able to handle that, they may just get bogged down in all these steps. I might go ahead and do that for them. Obviously, it's a lot less work on me if I can just have the students do it. And I think there's some valuable lessons to be learned there. Not every data set that you get in the real world is going to be immediately useful. Sometimes you do have to clean it up to get what you want. The dates also have a couple of those, so you may just want to watch out for that. You may have to unmerge a couple of these dates. Like I was saying before, the downside of this method is it's not as clean as what you would get in a textbook, but this is how it works in the real world. You're going to have to clean up your data if you're searching for real world data. Now, dates like this, I just go ahead and remove that. We're not going to be able to use that. All right. So I think my data is all clean now. One last thing that I need to do. I want to put these into Desmos, and Desmos is not going to be able to recognize July 6, 1912 as a number. Okay? And so what I like to do is I like to just say, okay, what's the world record time since 1900, or something along those lines. You could even go, since 1930 or whatever. But since I have my first date at 1912, 1900 seems like a good reference point, I suppose. So let's just go ahead, and I'm just going to override these with the last two digits. And unfortunately, I don't know a good way to have Sheets do this for me. If somebody knows a good function or shortcut method for it, please reach out and let me know. But so far, I've just been doing it the manual way. And so you can kind of see what I'm doing. I'm going to go ahead and pause the video so you don't have to watch me manually transcribe all these. Okay, so now that I've got it done, we're ready to take this over to Desmos. So now all we're going to have to do is, actually I'm getting ahead of myself. So if I copy and paste this into Desmos, the times are going to be my X column and the dates are going to be my Y column. That's a little bit of a problem because we would like the date to be the independent variable and the time to be the dependent variable. So we need to switch these. Okay, and so it's pretty simple. I'm just going to, highlight that column. We're going to cut it, and then we're just going to go ahead and paste it right there. And so now I've got my data arranged exactly the way I want. And I can just Control C to copy. We'll go over to Desmos. I've just got a blank graph in a blank cell. Control V to paste. And look at that. Notice that the window auto fits for my data. I've got one crazy one over here. I want to say maybe there could have been an error on me, or maybe we could go back and find that data point. This would be a good discussion to have with students, Did the user mess up, or was this just a really weird data point? Now, if you get to scrolling around, you've messed up your window. Notice a little magnifying glass shows up over here. You can zoom it back to that best fit. So, this is a great way to visualize this data. It's a great way to see kind of the trend. Obviously, as the years go by, we have this downward trend. We could, if you were doing linear functions, typically when I use this example, I'm doing linear functions, we can make Desmos give us a linear regression. So notice that when Desmos copies this list, it makes an X1 list and a Y1 list. And so we want the Y1 list to be our dependent variables. So we'll say Y1. Now instead of an equals, we'll do that squiggly. And then we'll have mx1 plus b. So we're just typing that slope-intercept form, only we're using our list names instead of traditional variable names. And you can see we get all those parameters. We get what the slope is. We get the y-intercept. We get our correlation coefficient. If you want to see residuals, you could plot those. So that's why I love this data set for linear functions. Now we get to talk about, okay, well, what does that slope mean? What does that m value mean? What's that b value mean? We can start making predictions. What's going to be the world record time, 20 years from now, 30 years from now? How accurate do you think this is? We could talk about correlation coefficient. There's just a million things we can do that is relevant to, the actual real physical world, because this data came from the actual real physical world. Now, another thing you can do is you can act on these X1 and Y1s just like they were a list of univariate data instead of, kind of bivariate data. And what I mean by that is if I wanted to find the mean of the X values, I could just literally type mean X1. And what I like to do sometimes is plot that on my scatter plot. And I'll do the same thing for the mean time. So y equals mean y1. Maybe I'll turn that red and dotted as well. Try to turn it red anyway. There we go. And then we can really start talking, this will divide this data into quadrants. And we can kind of talk about, okay, how come we see a lot of data in quadrant 2 and quadrant 4? We don't see a lot of data in quadrant 1, quadrant 3. We can make the observation that, of course, this regression line falls right at the intersection of both of these means. That's an interesting thing to note. I just think that doing this can help students visualize the data a little bit better and kind of talk about spread, talk about how the data lies and trends in the data. So I really, really like this example. I love using it for linear functions. But I just like the workflow as well. You know, I can get some data from Wikipedia, copy it into Google Sheets, do some cleanup work, and then copy that into Desmos, and everything just kind of flows, and everything works pretty seamlessly. I've worked this with, like I said, I've done it two ways. I've had students clean up that data and put it into Desmos, and I've done it myself. I do think it's more meaningful for students, but sometimes I will say students get bogged down in kind of that cleanup work, and they kind of miss the value of the assignment. So you do have to pay attention to the group you got. But you know what? I usually tell them that's the real world. The real world's messy. And if you want to get meaningful insight out of this data, you're just going to have to clean it up so that you can really focus in on what you want. So anyway, hopefully this example has helped. Hopefully you can use that and find some data sets of your own. There's a ton of good data sets out there. And you can start bringing real physical data into your math classrooms.